Alright, so this is part 5 of formulas and nomenclature. We're going to start off with binary acids. Writing formulas for binary acids, and one of the things we need to remember, is that for you to name a binary acid, it's always going to have hydro at the beginning. So hydrochloric, let's say. Acid. So all formulas for binary acid would start with H. So we can go ahead and put an H there. We know that's going to be the first part of it. And because it's binary, then what does that mean? That means 2 elements, all right? So if it's H, then there's only room for 1 more element. So what do? Well, we have to make sure it's a binary acid by the prefix. So if you see hydro at the beginning, then you know it's a binary acid. And the element that is connected is in the middle of the word. So chloric should tell you, okay, that means chlorine. So I'm going to write chlorine's symbol, Cl. And then we treat it kind of like an ionic compound, where we treat the hydrogen kind of like an alkali metal. And if it's in column 1, it's +1 charge. And chlorines, the valence of, are in column 17. And the halogens have -1 charge. And now we ask ourselves, just like we did with the ionic compounds, do they add up to 0? +1 and -1? Sure enough, they do. So we rewrite the symbols without the charges. And there's your formula for hydrochloric acid. Now, had they not added up to 0, we would have crisscrossed our numbers like so. So we treat the acid like a binary compound. In other words, we crisscross the signs if they don't add up to 0. And the symbol of the anion will be the root word of the name. In other words, chlorine. If it was hydrofluoric, that would be fluorine. If it was hydrobromic, that would be bromine, and so on. So let's take a look at some examples. Oh, well, hydrochloric acid, well, we just did this one. So let's just go ahead and click on that answer. Hydrochloric acid. Let's say hydrosulfuric acid. All right. How do we know it's a binary acid? We know that it's binary because it starts with hydro. And we also know that all acids start with H. And if it's binary, there's only 1 more element that can go here. And what element is that? Well, we have to go and look at the root word. I see sulfur right there. So what's the symbol for sulfur? S. And what's the charge for hydrogen? There again, it's always +1. And sulfur is a -2 charge. And again, if you're wondering where we're getting these charges, we have a charges sheet in our class, and you look on the sheet and you'll find that sulfur has a -2 charge. Does +1 and -2 add up to 0? Nope. So the 2 goes there, the 1 goes there. Do we write 1s in chemistry? Nope. We don't write 1s. So H2S is your answer. Hydrofluoric. Well, let's try this one. Again, how do I know that it's a binary acid? It starts with hydro. I know it's an acid, so it starts with H. I know acid is +1, or H is +1. And fluorine is the root word here, so what's the symbol for fluorine? F. Halogens have -1 charge. Do they add up to 0? They do. And if they add up to 0, we don't crisscross the numbers, and we rewrite HF. And then last but not least, hydronitric. So again, how do we know that it is a binary acid? We know that it starts with hydro. And how do we know that nitrogen is the other element? Well, again, the root word is nitrogen there. So what's the symbol for nitrogen? N. Charge for hydrogen, +1. Charge for nitrogen, if you look on your charges sheet, -3. What does a +1 and a -3 add up to 0? No, they don't. So my 3 and my 1 are going to switch. We don't write the 1. And our answer is H3N. All right, for ternary acids, it's really basically the same thing. Ternary acids start with hydrogen, just like binary acids do, and H is always +1. And the way you'll know the name is that the prefix hydro will be missing. So we say, for ternary acids, say no to hydro. That's what I teach in class. We know the monatomic cation is always the H+, and then we have to determine the ending. So let's do an example. It's much easier to teach it if we just do that. Let's say that I was having to write chloric acid, the formula. Well, the first thing I would look at is the beginning here. It does not have hydro, so I know this is a ternary acid. And if it's ternary, that means it's got 3 or more elements in it. Well, I know the first element's going to be H, automatically. Question is, what's attached to it? Well, automatically, if it has a total of 3 elements at least, then this ion that's connected to the H has to be at least 2 elements. What type of ion is that? Polyatomic. So the question is, how do we figure out which polyatomic ion we're talking about? Well, for that, you look at the ending of the first word. It ends in ic. If you see an ic ending, that means it was changed from ATE. So chloric was changed from chlorate. And we look up chlorate symbol, it's ClO3. And then we look up our charges, +1 and then -1. Do they add up to 0? They do. So our answer is HClO3. You'll never need parentheses on ternary acids because the +1 is always crisscrossing to the polyatomic ion. Now what if it had ended in OUS? Well, if it ended in OUS, that means that the ending was changed from ITE. So if that had been chlorous acid, we would have known that it was H, just like always. We would have known that it was ternary because of the absence of hydro, and we would have had to figure out what's connected to the H. Well, I know it's got to be a polyatomic ion, and it ends in OUS, so I would look up chlorite, and chlorite symbol is ClO2. And it also has a -1 charge, hydrogen +1. So again, they do not cancel, or excuse me, they do cancel, and my answer would have been ClO2 for chlorous acid. All right, let's try some examples. Sulfuric acid. All right, well, how do I know that this is definitely ternary? No hydro. I know it starts with H though, +1 charge. And then I go over here and I look at the ending of sulfuric. And I go to my notes and it said it had an ATE ending. Now don't go look for sulfurate. Some of these are changed slightly. There is no such thing as sulfurate. So actually what you're looking for is sulfate. And sulfate is SO4. And it has a -2 charge. So do they add up to 0? They do not. So the 2 is going to crisscross to the H. The 1 goes down here. We don't write the 1. And my answer is H2SO4. Nitric acid. Again, how do I know that nitric acid is a ternary acid? Well, there is no hydro. But I do know that it starts with H. And then I need to figure out what polyatomic ion is attached to it. Nitric ends in IC. That means nitric was changed from nitrate. I look up nitrate, it's H. It's NO3. It has a -1 charge. Hydrogen has a +1 charge. They add up to 0, so no crisscrossing. And there's your answer for nitric acid. Nitrous acid. Again, how do I know? It's a ternary acid. No hydro on the front. But I do know it's an acid because I know that it starts with H. Now, OUS ending. Nitrous, what did that change from? Well, the notes said nitrous changed from nitrite. Nitrite is NO2. Got a -1 charge, +1 charge. They add up to 0. So if they add up to 0, no crisscrossing, HNO2 is the answer. Hypochlorous acid. Now be careful here, this is tricky because hypo looks like hydro, but that is not hydro. That is actually the name of a polyatomic ion. And how do we know what it ends in? We know it ends in ITE. So we're looking up hypochlorite. And when we do that, we see that it's ClO. Well, aren't we missing something on the front here? Don't all acids start with H? They do. +1 charge. ClO, -1 charge. Add up to 0 in that case. HCl is the answer. And last but not least, phosphoric acid. Again, we know it's a ternary acid because there is no hydro. Phosphoric ends in IC. So what are we looking for? Well, we're looking for phosphate, not phosphorate. Again, you just have to get used to it. Phosphate is PO4. It has a -3 charge. Hydrogen has a +1 charge. Does a +1 and a -3 add up to 0? They do not. So we crisscross the 3 there. The 1 would go there. We don't write the 1. And our answer would be H3PO4. That's part 5 of the Formulas and Nomenclature PowerPoint.